Welcome back to pre-calculus. I hope things have been going well so far. Today we're going to talk about matrix operations. Before I can talk about matrices, I want you to understand what they really are. A matrix is simply an array of numbers. And this array is kind of like a grid, just without the grid. That's part of the reason why it's called an array. And I'm going to give you an abstract form of a matrix, and I'll give you a definite form. So the abstract form, if we were writing this and it's 4 columns by 3 rows, we would have terms in each one of these places. So 1, 2, 3, 4 terms, and then 3 rows of these terms. Usually we use a capital letter to denote a matrix. And then inside the matrix, each one we call a little letter. So since this is capital A, this would be little a, and it's in the first column, first row. And then the next one would be little a, first row. It's first row, first column, first row, second column, little a, first row, third column, little a, first row, fourth column. And then we'd go down in the same direction. Little a, second row, first column, little a, second row, second column, little a, and then we'd have 2, 3, a, 2, 4, a, 3, 1, a, 3, 2, a, 3, 3, a, 3, 4. Okay? So this is 3 rows, 4 columns. Okay? Now, a dimension, the dimension of this matrix, we always list rows by columns. Rows by columns. Okay? So the dimension of this, we would say, is a 3 by 4 matrix. Now, these simply represent numbers. They're like x's. You could have 12 different x's here, but this little a represents a number in this position. Okay? So, for example, I could write 1, -3, 5, 2, oops, I can't do that many. I need more space here. 5, 2, 7, 9, 8, 4, -6, -2, 27, -0. Let's just put a 0. There. So, I'm looking at this, and this is my array. It could be my matrix. The number in position 2, 3, A2, 3, that's the second row, third column, is 8. Okay? Now, we have special matrices that will come into play later on during this class. We can have a row matrix. Our rows go in this direction, so we could have a matrix that's just one row like this. And a row matrix from here I could say is 7, 9, 8, 4. It's just one row. We could also have a column matrix. This is just one column. Okay? 2, 4, 0. A square matrix is where the dimensions match. The rows and the columns are the same. So we could end up with a square matrix of, let's do a 2 by 2, 5, 6, 8, 10. Okay, there's a square matrix. The columns and the rows match. A 0 matrix is whatever dimension you want it to, but every single term is 0. So I could have it like this, and we can go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's a 0 matrix. Every single element, every position is 0. Each one of these is called an element, and here every element is 0. Now, if you have two equal matrices, this means every element is the same. So if I have A equals B, that means whatever A is, so if I say 1, -4, -3, 5, B has to be the same thing. 1, -4, -3, 5. Every element must match. This is only true if every element matches. So let's do a real quick example, and then we'll get to adding and subtracting and multiplying by a scalar. So here, what is in position A22? The answer is 36 because it is in row 2, column 2. How about 2-1? The answer is 24, row 2, column 1. Go ahead and try these others. Pause the video, try the others, and I will do them when you come back. All right. So, 4-3, fourth row, third column, 29. First row, third column, 28. Third row, second column, -11. Third row, fourth column, 17. Hopefully you have these same answers. I did it right too. Okay, so I want to work through some problems here with addition and subtraction and some multiplying by scalars, and we'll actually solve an equation using this. So, starting off here, I need to take a look at these values. When I am adding, so when I'm adding W and X, I'm adding this matrix with this matrix. The matrices must have the same dimension. So this is 3 by 2. Is this matrix also 3 by 2? If so, then I can actually add them. If not, then I'd have to stop and say, well, I can't do this problem because it won't work. So I'm going to start by copying my matrices down, and I'll show you how to add them. 13, 2, -4, -6, -10, 8, plus 1, -3, -5, 9, 12, 7. To add these matrices, I add the corresponding elements. So, this is the only one that I'm going to write this out this way, so bear with me. 13 plus 1, 6, -6 plus -3, 2 plus -5, -10 plus 9, -4 plus 12, 8 plus 7. And then I can take and I can add each one of these and solve each problem. I always like to joke that this is a way that math teachers can make you do a bunch of simple addition and subtraction problems all at once. And so I think we should teach this to little kids, and then they can just add this, and you can come up with two matrices and say add all these, and you can test all their addition and subtraction. All right, so 13 plus 1, 14. -6 plus -3 is -9. 2 plus -5 is -3. -10 plus 9 is -1. 4 plus -4 plus 12 is 8. 8 plus 7 is 15. And there's my answer. All right. Here, I'm going to write these, but this step, if you need to continue writing it, go ahead and write this step. but I am going to not necessarily write this step every time so that the video can be a little shorter. I feel like I'm giving you guys really long videos every time, and I'm hoping I'm not boring you too much. I'm not there to find out if I'm going too slow or too fast, and I miss having the classroom and being in the classroom with you guys. Alright, so y minus z. So I'm going to start by copying y and z down so that you guys can see it here. 5, negative 2, 1, negative 6, 14, 8. Minus negative 11, 3, 7, 4, negative 9, 16. To subtract, I'm going to do just like what I did for adding, and I'm going to subtract the elements in the same position. So 5 minus negative 11. Well, minus negative 11 is plus, and so 5 plus 11 is 16. Negative 2 minus 3 is negative 5. 1 minus 7 is negative 6. 6 minus 4 is negative 10. 14 minus negative 9, well, minus negative becomes positive, so 14 plus 9 is 23. 8 minus 16 is negative 8. And that's my answer. Now, take a look at y and w. I need to do y minus w. It won't work because when I try to take this term and subtract something off, when I take this position, 1, 3, y 1, 3, and I try to subtract w 1, 3, well, w has 1, 1, 1, 2, but no 1, 3. So this does not work. No answer. Or you could write not possible. The dimensions will not allow me to answer that problem. All right, so let's work on this one. To multiply by a scalar, you're going to multiply every single term by the answer. So let's write this out. 3 times my x is 1, negative 3, negative 5, 9, 12, 7. Minus 4 times 13, negative 6, 2, negative 10, negative 4, 8. So my first step here is to multiply this scalar into each matrix, and then I can do the subtraction. So multiplying my scalar in, I'm going to multiply every element by my scalar. So this first matrix becomes 1 times 3 is 3, 1 times negative 3 is negative 9, negative 15, 27, 36, 21. My second matrix, I'm going to have the minus, and you multiply each one of these by 4. So 4 times 13 is 40 plus 12, which is 52. Negative 24, 8, negative 40, negative 16, 32. My last step is to subtract each place. Okay? So 3 minus 52 will give me a negative 49. Negative 9 minus negative 24, well, that's plus 24. So now I have negative 9 plus 24. That is the same as saying 24 minus 9. 24 minus 9 is 15. Negative 15 minus 8 will give me a negative 23. 27 minus negative 40, that's plus 40, will give me a 67. 36 minus negative 16, well, that's going to be plus 16, so that's going to give me a 52. And 21 minus 32 is going to give me a negative 11. And there's that answer. So now for our last problem. Sorry, that 3 just doesn't look good. What if I have a problem like this? A is a matrix. I don't know what A is, and I need to solve for A. Well, 1/2 of A is 3z plus y. I know what z is, and I know what y is. Half of A I don't know. So to get rid of this half, I'm going to multiply everything by 2. Just like if I were solving for x, I'm solving for this. So I'm going to get A equals 2 times 3 is 6z plus 2 times 1 is 2y. Now I can actually solve what A is. So A equals, now I need to do 6 times z. Well, z is negative 11, 3, 7, 4, negative 9, 16, plus 2 times what y is, and so y is 5, negative 2, 1, negative 6, 14, 8. Now I can solve it just like I did in the last problem. So now I'm going to multiply each one of these by the scalar. So I'm going to get 66, 18, 42, 24, negative 54, and 6 times 10 is 60. 6 times 6 is 36, so 60 and 36 is 96. Plus, now I'm going to do 2 times everything in here. That's 10, negative 4, 2, negative 12, 28, 16. Now all that's left is to add. So A is going to be this matrix that I'm going to add up right now. 66 plus 10 is 76. 18 minus 4, or 18 plus negative 4, is 14. 42 plus 2 is 44. 24 plus negative 12 is just 12. Negative 54 plus 28. Well, 54, since they're opposite sides, I'm going to subtract. So 54 take away 30 would give me 24. This is 2 more than 30, or 2 less than 30. So I'd say instead of 24, 26. And then 96 plus 16 will give me 112. And there's my answer. Sorry you couldn't see that. All right. That is all that you need to solve for today. That is the matrix problems that we are doing now. They will come to play again. We will cycle back around to matrices. So make sure you understand these. It's fairly simple. Lots of just regular arithmetic that you guys should be used to. Hopefully this homework will be somewhat relaxing. Enjoy the rest of today and prepare for the test tomorrow.